Hello everyone, in today's video I want to show you how to use binary trees breadth search to solve these three LeetCode problems. And first we should see the definition of tree node. In the tree node we have the value and we have the left node and the right node. For example, if this node is root node and it has the value 4 and have the left node 7 and the right node 6. How to retrieve the 4 value? You should use root.value to get the 4 value. And how can we get the 7 node? We can use root.left and the root right will be this 6 node. And what is a breadth search? A breadth search is like we traverse from this root node. We should go the trail node first and follow the same rule. Traverse the child node first. So this is like traverse in this way. And compare with the differ search, DFS traversal. If we have the same tree like this, the differ search will traverse in this way. So it's more like this way. So breadth search is like this way, and the differ search is like this way. And dive into the 102, the LeetCode problem 102. These problems say the binary tree level order traversal. As we can see the output, we should make the answer like this 3 and 9, 20 and this 15, 7. Okay, so it's very intuitively know we should traverse the tree like this way, so we can use the breadth search. And how can we implement the program to return the right answer? If we want to implement the breadth search, we usually use the data structure called a queue. And the queue is the data structure have the property like we can put the data from this way and get the data from this way. So as we can see, the problem is given the root, so we just know the root and how we do the traversal. In this problem, I would like to use the temporary queue to do the levels separating. And so let's see how to do this problem. The first, we have the queue and have the temporary queue like this way. And I want to set the initial situation in this problem, so the root node would have been traversed. So in my answer I have the 3, and the 3 node will be in the queue. So if the queue has the 3 node, we should pop out this node and do some process. So if the node pop out, we should check this node has a trial node or not, and this node 3 node has the 9 and 20, so we can put in the 9 and 20, and we have checked these 2 nodes, so we can get the answer in this way, right? And in the detail, how can we know this level have been traversed? It is we can check the queue has a value or not. If the queue don't have the data in the queue, if we don't have the queue don't have the data in the queue, we can know the levels have been traversed, so we can get this data. And the 3 is processed, and we can update the queue to the temporary queue. And the queue have the data again, right? Has the data again, right? So we pop out the 9 node and check if the 9 node has the trial node or not. It's not it doesn't have the node, so we can skip, we can do nothing, and pop out the 20 and check whether it has the trial node or not, and it has 15 node and 7 node. And in the temporary, we have these 2 node, and we can add this to our answer and update to the queue 15 and 7, and we should pop again, right? But if 15 node and 7 node doesn't have they don't have the trial node, so we have done the traversal. How can we know we done the traversal? Is a queue doesn't have any node again, and we could return the answer. And let's see how can we implement it on the LeetCode. As we mentioned, we can do the queue. We can use the queue, and we should set up the initial situation. So pen root, and is our answer. I like to set the levels. Root value, and as we can see in this initial situation, we think the root has a value, so we should consider if not the root, we should return the empty list, and we can set up a temporary queue to do the level separate while queue have the data in here in the queue. How can if we have the data in the queue, we should keep doing the traversal. So we can from the queue to pop out and we can use the pop left to get the data, and check the node has the left node. We can put it into the temporary queue, and check the node has the right node or not, and node, and how do we know we should append the temporary queue to the levels? Okay, let's think about it. We should make sure the queue doesn't have any data. Okay, and we can write the if not queue, and we can check the temp again, and we can append the data in the temporary queue, and we should convert them into the value. So we can write this way. I want to make sure you understand why we write the if not queue, because if we doesn't make sure the queue have the data or not, we may keep doing the append. We can maybe we could keep doing append data in the values, and the values would be separate too much levels. And if we down the append data into the levels, we should update the queue to the temporary queue, and the temporary queue should be refreshed to be empty queue. And if we down the traversal, we can return the levels. Okay, let's check the answer. Oops, append the queue. Oh, sorry. Append append. Okay, let's submit. Okay, this is the right answer. And back to the another two problems. As we can see these two problems. This problem, you want to return the deepest leaves, and there is a summation of the values. So it's easy to return just levels, the last element, right? And just do the summation. Okay, and this binary right side view, we should think about how to retrieve the this node, and you can use for loop to process the levels again and retrieve all the last node. Okay, but I prefer to do this in the program process, and I will implement it and explain how to do it as well. So we can use the same code and just modify it. I think this problem is easy. If not root, we just return the 0, and if we have the root after traversal, we can just do the summation in this way, and let's submit. Okay, it's the right answer. Okay, and the last one is how can we do I want to use another result, and in the initial situation, the root node should put it into the result, and we can do in the levels append. Okay, we can do like this way, result append levels, the last one. Oh, it's append this way, and we can return the result. Okay, let's check. Oops. Result. Why? Invalid levels. Oh, sorry. Let's do this way. I think this way is better. The value. Yeah. From the temp is a one levels node, right? And we just retrieve the last node and got the value. Okay, is the right answer. Okay, so it is today's video share the buffer search, how to solve these 3 LeetCode problems. Hopefully this video will help you understand the tree node or binary tree or the buffer search. And if you like this video, please sorry. If you like this video, please hit the like button, and hope this video will help you. Thanks for watching. Bye bye.